In this video, we're going to continue with Chapter 2 material, and we'll look at some of the examples from Chapter 2. And these are the PowerPoints that we're going to be focusing our attention on. So in the previous lecture, we went through some of the concepts, some of the main ideas of Chapter 2. And here we're going to put these building blocks together. And before we get into some of the examples, let's talk about some of the programming style conventions having to do with Java. In different programming languages, you might see different, when I use the word conventions, I mean kind of the way coders do things are similar in some languages and different in others. And so in Chapter 2, they talk about some of the conventions for programming style, specifically related to the Java programming language. So there are a few things that they talk about in the textbook. I'd like you to read that. First of all, about the importance of comments. This isn't new. This isn't unique to Java. This is something that would be true in any programming environment. You want to make sure that as you are doing your coding, you're kind of explaining what's going on in your code. And the reason for it is that probably you're not the only person who's going to have to read that code. If you're in a professional environment, you're working with other coders. And even if you're doing your own programming all by yourself, still eventually somebody else is going to have to look at that. Or maybe you're going to have to look at it. And you're going to try to remember, what was I doing here with all of these looping and nesting of loops and all that kind of stuff. So putting comments can save you some time in the long run, even though it might take a little time in the short run, because it gives you a better understanding of what your code is really doing. This notion of indentation is something that you were forced to do in Python. You could not write your code without indentation in Python. In Java, you can, and nevertheless, it's not easy to read if you don't do proper indentation. So that's going to be also something very important. The notion of block styles, where do we place our curly Q braces? We'll see some options for that. And one of the nice things having to do both with indentation and with block styles that you get with NetBeans is that you can easily, just with a click of a button, have NetBeans automatically format your code for you so it's more readable. And I'll show you that in a little bit. And then there are various naming conventions. Well, how do we name our classes? How do we name our methods? And remember what a method is. A method is either a function or a procedure. It's a member of a class. So how do we name them? How do we name our variables? And as you'll see, as we look at all these examples, the convention in Java is that class names are going to begin with an uppercase, and method and variable names will begin with a lowercase. And constants are all uppercase, and this notion of what's called camel case, where if you have multiple words in your name, that the first letter of each word, the subsequent word would be capitalized, and we'll see examples of that as we move through our coding. In Python, the comment was with a pound sign, and that was a single line comment. In Java, for a single line, it's 2 forward slashes. And Java has the option for multi-line comments, where you would begin it with a slash and an asterisk and end it with an asterisk and a slash. In Python, there's really no such thing as multi-line comments, although you might have faked it by putting 3 consecutive double quotes, and then everything following those 3 consecutive double quotes is basically part of a quoted thing, literal, and then ending it with 3 consecutive double quotes. And that basically is almost kind of like a comment. It's not really literally a comment, but sometimes people do that. But in Java, you actually can have a multi-line comments using this slash asterisk and asterisk slash. And we'll see a lot about how important indentation is. Statements within a block should be indented. Anything within a class will be indented. Anything within a method will be indented. Anything within an if statement will be indented. And as I said, you were forced to do that in Python. You're not forced to do that in Java, but it's definitely better practice to do that than not, because otherwise it's going to be a very difficult to understand the code. In a way, you can think of indenting as being kind of like an outline. Your algorithm you can think of as being an outline of major sections, and then within that subsections, and then within that subsections. And it's the same kind of idea with the indentation when you're coding. And when they talk about block styles, you're going to have an open curly Q brace and a closed curly Q brace for any block. And so if I have a method, do I want to put the open curly Q brace under the name of the method, or do I want to put it at the end? Either way is fine. You'll notice that when you do your formatting in NetBeans, if you do this automatic click of a button to format, then it will do it this way. Again, with the naming conventions, if you have variable names, you're going to start it with the lowercase. If it's several words, you're going to kind of put them all together and capitalize the first letter of each subsequent word. That's what the idea of camel case is. So you see the capital A here. It's easier to read compute area when you have that. You can kind of distinguish between one word and the other rather than just have it be a lowercase. It all kind of just melds together. So this notion of camel case is very commonly used in Java. In other languages, you might see more like when they're separating words out, they'll use an underscore instead of camel case. It's perfectly acceptable to do it, in terms of the program, how the program works. But within the overall Java community, you're going to see a lot more of this than you're going to have with the underscore separating the words. And also, when we look at the Java documentation, you'll see that this kind of approach to naming methods or variables is ubiquitous in Java. And for class names, capitalize the first letter of each word. If we have a class called test compute area, you'll notice the capital T, the capital C, and the capital A. And then for constants, again, the convention is to be all uppercase for a constant. So that way, when we see the name of something, just by looking at the name of it, we can kind of tell what it's supposed to be. Is it a variable? Is it a class? Is it a constant? So when I grade your programs, one of the things I'm going to want to make sure of is that your code is written in an appealing aesthetic way and that it is easy for the reader to understand. And so this notion of comments, this notion of indentation, and this notion of following good naming conventions is going to be something I'm going to be looking at. Of course, the most important thing is that your code works and that your code is running efficiently and it doesn't have a bunch of extraneous stuff in there. But this notion of indentation and naming conventions is definitely going to count. As I said before, this textbook has a lot of really great examples, and for every chapter we go through in the textbook, I'm going to be diving in depth to some of the examples from that chapter. So in Chapter 2, I'm going to focus on these three classes that you'll find in the Chapter 2 package: ComputeArea, ComputeAreaWithConstant, and ComputeLoan. All of these have some useful tidbits to show you about the Java programming language, and so we'll be going through each one of these. And if you look in NetBeans, in the NetBeans project that I gave you, this Liang 11th edition samples project, and we look in Chapter 2, here's that compute area, here's that compute area with constant, and then here was the compute loan. And there's others that are useful as well, but the ones that I'm going to spend most of my time talking about are these three. So here's the first one, the first class called ComputeArea. This is in a file, a source code file called ComputeArea.java. Remember, all source code files end with a .java file extension. And as you can see by looking at this, we're doing some indentation here. So here is the class, the beginning of the class. Here's the curly Q brace for that beginning of that block. And here's a curly Q brace ending it. And then within that, the method is indented. And that method has a block. Here's the begin. And here's the end of that. And within the method, there's indentation. And notice that even within this one instruction right here, this one program statement, which actually is wrapping around a couple of lines. Now remember, you could do that in Java. You can't really do that in Python without a special continuation character. But because in Java, all statements end in a semicolon, well, the compiler can look to see where's the semicolon in order to know when the statement ends. And notice that this statement, even the remaining part of the statement, is indented as well. So you always see what's subordinate to something else by virtue of the indentation. That's why indentation is important for readability purposes. And this class is part of a package. That package is called Chapter 2. What's a package? A collection of classes. In practice, the package is a folder in your directory. And so there's two things you have to do. You have to put your Java file in the appropriate folder, and you also have to write the package statement with the appropriate package name, which is going to match the folder name as the first line of code in your Java file. And so we're going to see that most of the examples that we're going to go through this semester, classes are explicitly going to be shown to be part of a package. So here I am again in NetBeans, and if I pull up ComputeArea, that's part of that package. And if I pull up ComputeLoan, that's also part of that package. And if I pull up ComputeAreaWithConstant, that's also part of that package. So all of these classes, every single one of these classes, are part of the Chapter 2 package. In other languages, they might not use the word package. They might use the word namespace, for example. But in either case, what we're talking about is a collection of related classes. I don't think we have any examples of sub-packages in the Liang project, but you might have packages that have sub-packages and sub-packages within that. So here we have, within our main method, we have declared a couple of variables. Again, in Python, you didn't have to do that. There was no such thing as declaring a variable in Python. But here, in order to use a variable, you have to first declare it. And recall from what we talked about before that a variable declaration involves specifying the data type and then also specifying the name of the variable. So what that means is that since radius is a double, I can't put a string in there. I can't put anything other than a number in there. I can put an integer number because remember there's automatic type conversion taking place. So if I assign a 20 into radius, it's going to wind up being a 20.0. But I can't put a string into there. Bottom line, variable declarations have to take place prior to the use of the variable. Also, I might note that these variables right here are local variables. They're called local variables of a method. So there's the main method, and it has these two variables. If I had another method in my class, that other method would not be able to access these two variables. The only statements in the code that can access these two variables are statements within the main method. And furthermore, are statements within the main method that come after the declaration of these two variables. And here's where we're using the variables. We're assigning values into it. So remember the assignment operator, which is a single equal sign. And always, 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 as I've said before, what's to the left of the assignment operator is the name of a variable, the identifier of a variable. And what's to the right of the assignment operator is some expression that will produce a piece of data that is consistent with the expected data type of the variable. So this particular expression was just a literal, 20. Just the 2 and a 0 typed in your code, that's a literal. This expression involves arithmetic operations, working on variables and a literal. And then finally, in this very, very simple example, we are printing something out to the console window. And what are we printing is the concatenation. So here a plus symbol is not adding, it's concatenating. A concatenation of this string with this variable which contained the number 20, but that has been automatically converted into a string. And then this string, and then this variable which has whatever the result of that arithmetic expression was. All of those things being concatenated together. Now we see system, and we see out, and we see print line. So let's try to make some sense out of that. So system is a class. And remember the naming conventions. Class names begin with S. This is a class that is part of the Java API. I'll take you to the documentation shortly to show it to you. One of the member variables that is in the system class is called out. We'll take a look at that as well. So this is the name of a member variable called out of the system class. Out is the standard output stream. In other words, that's just the console window. When system.out.println occurs, it's printing whatever is in this value right here out to the console window, which in NetBeans can be seen in the output. But if we were running this just in Windows from the DOS command prompt, then it would just appear there. So out is a member variable. It's a variable of the system class. And by the way, it's a static member variable. I'm going to be using that terminology and be making this distinction between static and instance later on in the term. There are instance member variables and there are static member variables. This is an example. Out is an example of a static member variable. Now that static member variable itself is an instance of a whole other class. And that other class is called printStream. I'm going to show you that in the documentation as well. And so a printStream object includes some methods. One of the methods is called println, P-R-I-N-T-L-N, which is going to do what? It's going to take whatever the contents of the argument that's passed to it, and it's going to print it, and then it's going to go to the next line. There's also one that's just called print, without the line at the end, and so it doesn't go to the next line. So if you wanted to print something and then print something else on the same line, you wouldn't use print line, you just use print. And this is an example of a method that does not return a value. Some methods return values. Those are like, in a sense, you think of those as being like functions. And when you normally think about functions in programming parlance, we think we're calling something, it's going to do some behavior, and it's going to give us back a piece of data. And in that sense, a function is also an expression because it's giving us a piece of data. But that's not true for println. Println isn't giving us back a piece of data. All it's doing is it's performing some behavior, specifically printing something out to the screen. And that's it. Println would therefore be what's often called in Java a void method, as opposed to a method that returns data of another type like int or double or string or whatever. Println returns void. As always, it's good to go to the documentation to get useful information. And so let's take a closer look at the system class. This is part of also, system is also part of the java.lang package, which is a package that you always are importing by default. Some packages you have to explicitly import, and we'll talk about that later when we come to it. And some packages just, in one package I should say, the java.lang package, just is always going to be part of your program no matter what. So in java.lang, we have a number of classes. We also have these things called interfaces. I'll talk more about interfaces later in the semester. But we have these classes. One of the classes was string, remember. And we'll look at that again in more detail later. But another class is called system. So what are we talking about with system when we're looking at this documentation? Here's our class called system, which is part of the java.lang package. Something to understand is that the full name of a class includes the name of the package. So the real name of this class is java.lang.system, which is a subclass of object. And later we're going to see that object is basically the granddaddy of all of the classes in the Java class library. And we'll talk about that a little bit more later on in the semester. And there are a number of, there are actually 3 different member variables, fields. The term that they're using here in the documentation is field. So field, member variable, attribute, same kind of idea. And one of them is called in, and the other one is called out. In is the standard input stream. That means the keyboard. Out is the standard output stream. That means the screen, the console window. What I really mean to say as a stream is that it is a flow of data. So in is an object that represents a flow of data from the keyboard into memory, and out is representing the flow of data from memory out to the screen. And then there's a bunch of methods. Lots and lots of methods. And not that many, really. There's other classes that have more. And a few of those methods begin with the word, no, this is not the print. So there are some methods here. These will be some useful methods maybe later on. We'll talk about these methods later. We won't worry about those. But I would like to take us to the print stream class. And we'll look at one of the methods of the print stream class. So I'm going to go ahead and click here on print stream. And you'll notice what it says here is that it is a class in java.io, yet another package. There's a java.io package. Let me show you that right here. Java.io is one of the packages. So if I'm going to click on print stream, let me do that. It takes me to print stream. What is print stream? Print stream is a subclass of filter output stream, which itself is a subclass of output stream, which is a subclass of object. And print stream has some methods, including a couple of methods here that we'll look at. Methods called print line, which is what we were looking at. And actually, you can see there's different versions of print line. Print line where it takes a boolean, print line which takes a char, print line which takes an array of chars. Go down a little bit further, print line which takes a string, which is what we're actually doing. This is an example right here of what's called method overloading. We're going to talk about method overloading also later in the semester, where you can have methods of the same name, but depending on what's the data type of the arguments that are being passed, they're actually separate, different methods, even though they have the same name. So these were print lines, and I think also above we see some print methods as well. As I told you, there's methods that will just print and not go to the next line. And then there's also nice methods for printing with certain formats. We'll probably run into doing a little bit of that as well later on. So basically, a lot of this is about printing, right? The print stream is about printing. So to get back to this method call here that we broke down, system is a class. That class had a static member variable called out. That was an instance of the print stream class. So it's a print stream. And so we called print line on that print stream. And then we printed this out. So here's the code of ComputeArea. And if I run it, I'm just going to go ahead and right-click here, and I'll say Run File. And when I run it, it's going to give me my output, which is saying the area for the circle of radius 20.0 is this number, 1256 point whatever. Sometimes the output might not be so easy to see, so if I right-click in this output window, you can see I can decide I want to make it a little larger font or a little larger font. It looks like the control and the up key also does it. So nice little features of the integrated development environment. maybe I'd like to debug it and see what it looks like. So what I'm going to do now is I'm going to actually sprinkle a few breakpoints here and see what things look like. So I'm going to put a breakpoint at line number 12. So if I just click on line number 12, you can see that there's a color here. And I'm going to, maybe I'll put one at line number 9 as well. And then maybe I'll also put one right here in the system.out.println line as well. And let's see what we can do with that. So now I'm going to right click, and rather than running it, I'm going to debug. And you can see that we've stopped at this breakpoint. So if we stopped at this breakpoint, here we have a variable called radius. We've declared a variable called radius and a variable called area. And nothing has come out yet. But we can see that we have some variables here, but the only one we really see here is args, because although these have been declared, they actually haven't been used yet. And the NetBeans debugger is not going to show us them until they start being used. So what I'm going to do now is I'm going to advance. I'm going to go to the next step. And up at the top, then this little green button is to continue. So I'm going to click continue. And that took me to the next line. And notice that we now have a variable called radius. That radius is of type double. And the value is 20.0. Remember, we assigned 20 into that, an integer. But what did it do? It automatically did the type conversion. It automatically did type casting. And remember from the previous set of slides, I talked about typecasting and distinguish between implicit and explicit typecasting. This was an example of implicit typecasting because it automatically did it for us. Because an integer is a smaller piece of data than a double, and so there was an automatic conversion to the larger data type. But you'll see that we still don't have area yet. Now I can tell what's going to happen to area because I can look at, for example, at radius. Let me hover over radius. Look, it's showing it's a 20. Here's another 20. And then we have this literal value. If I want to see what's it going to look like, let me just select all of these and I'll hover over that and it's telling me it's 1256.636. Or if all I wanted to see was what's radius times radius, I could hover over that and it's telling me that it is 400. And of course, now when I go to the next statement, and now we can see that we have the value 1256.636. And I can even see what's the value of this whole string going to be. If I want to hover over this whole thing that's inside the parentheses of our method call, and I want to see what it looks like, and there it is. The area for circle of radius is you can see what it says there to the right there in the tooltip. The area of circle radius 20 is 1256.636. So hopefully you're beginning to glean the usefulness of a debugger. So that was our first little example from chapter 2. The next example is making use of two features that we'd like to discuss. One is that we're using a constant, and the other thing is we're actually taking input from a user. Let's look at this one. This is listing 2.4, and let's kind of step through this one a little bit. So here's this notion of a constant. How do we make a constant in Java? Through the use of this modifier called final. So final is a modifier, and it's modifying this to say that this thing called pi is not a variable, it's a constant. It is of type double, and it's been initialized to this value. And after it's been initialized, we can never change it again. So that's us using the constant, creating the constant, I should say. And here's where we're using the constant. We're using the constant in this expression. So that was one thing. Again, notice the naming convention, PI, all capital. And again, let's look at our naming conventions. The class name, using camel case, multiple words here, beginning with a capital. Here was a variable name, it was only one word, began with a lowercase. Here is another variable, only one word begins with a lowercase, right? And also look again at the indentation, as I showed you before. So that was the use of a constant. And now let's talk about the use of how we are going to do user input from the keyboard. And there's a very useful class, which is part of the java.util package called scanner. Now, the scanner class is part of another package, is not part of java.lang. Java.lang had, system was part of a java.lang. So I didn't actually have to import java.lang, but you'll notice that I do have to explicitly import java.util. In this case, we're just explicitly importing the one class from java.util. There's lots and lots of classes in java.util. If I wanted to import all of them, which I could just say import java.util.star, and it would import all of the classes of the java.lang package. But in this case, we're only importing the scanner class. So let's talk a little bit about what the scanner class does. There are many ways to do user input. The scanner class is one pretty simple way to do it. And the scanner class can also read from files as well. We'll use the scanner class later in the semester to read from text files. In this case, we're just going to read from the standard input stream. And what's the standard input stream? Remember, it's system.in. I was showing you the system class and the variable called in, which was part of the system class. And so that's what we're using when we're reading from console-based input. And there's a lot of useful methods. Next byte, next short, next float, next double, etc. Next line also will be another possible example. And so we're going to be making use of that. So if we look at our code, number one, if we want to use a scanner, we had to explicitly import it or the package that it's in. If you have multiple classes in your own package and you want to use them, you don't have to import your own package. If I have another class in Chapter 2 that I want to use, I wouldn't be importing Chapter 2 because this class is in Chapter 2. And I also don't have to import java.lang. But any other package that you're going to be using, you have to import it. And here is where we're instantiating a scanner object. So we're creating an instance of the scanner class. So the scanner class is something that you create instances of. We didn't do that with system. System, we were just making use of static variables. We didn't create an instance of system. So not all classes are intended for creating instances, but scanner is, and many, many are. Scanner is not something that is going to be a program. It's going to be something that's going to be an object that you're going to use within our program. So we're creating an instance of this scanner class. We're passing as an argument the stream that we want, and it has to be some kind of an input stream. It doesn't have to be the standard input stream. In our case, we're using the standard input stream, but any kind of a stream that is taking data from some external source and bringing it into memory, we can be using with scanner. And as a result of this, the variable called input, when this statement is done, is going to be a reference to a scanner object. That's distinct from, for example, this variable called radius, which was of a double data type, meaning a primitive data type, will have actual data in it. But this variable called input is not going to have actual data in it. It's going to be pointing somewhere else in memory where the actual data resides. That's the distinction between variables that contain values, i.e. variables that are of primitive data types, and variables that point to objects, which are variables that are non-primitive data types. And remember, there were only 8 data types that are of primitive types. And here we're calling a method of the scanner class. This particular method is an instance method. I'm going to be making distinctions between this notion of instance versus static. Throughout the semester, it's time to start to kind of get used to that terminology. You're probably not going to get a a real good feel for it until later when we get into object orientation, but at least I want you to start to get exposed to the ideas. Basically what happens when we get to this statement right here, in order to be able to put something into radius, this expression has to be evaluated. In order for this expression to be evaluated, the user has to type something and hit enter. And only then will that value be placed into radius. And by the way, if the user typed something and didn't put a value that was consistent with the double data type expectations, and we tried to assign it into there, we'd get an error. I'll show you that when I run the code. So here we are in NetBeans. I've got ComputeAreaWithConstant open. I'll go ahead and run it. And notice that it's asking me to enter a number. It's just going to sit there forever until I enter a number. I'll go ahead and enter a number. I'll enter a number 10. And then it gave me the result. Let me show you what happens if I didn't enter a number. Let's say I entered the word hello. And in this case, what I got was an exception, an input mismatch exception, because I'm trying to read a double, but the user didn't enter a double. This is an example of an exception. Let me talk a little bit about the different kind of errors that you're going to encounter. One error that you're going to encounter is a syntax error. And we talked about that back in the very first lecture. Syntax error means that you're not following the grammatical rules when you type your code. Another kind of an error that you might get is called a logic error. And what this means is that the program runs, but it's not giving you the right results. Those are sometimes the hardest to track down. I would say the logic errors are the hardest ones to track down and figure out what's going on. And another kind is an exception, which means basically that your program is going to blow up, it's going to abort, or you have to deal with it in some way. Perhaps you remember exception handling in Python, and we're going to do exception handling in Java as well. And here was an example where we had an exception. If we were going to handle this a little more gracefully, we'd be saying, sorry, you gave a bad number, please try again, something like that. And we'll get to that exception handling stuff later on. So if I run it again and give it a legitimate number, this time I'll give it a number 32.56, and you can see that it's working as well. Let's set some breakpoints and see what's happening in memory. So I'm going to go ahead and set a breakpoint maybe right here. And I'll go ahead and debug it. So I'm going to enter a number, 25, and now it's stopped here. So let's take a look at what's going on in memory. If I want to look at my variables, and by the way, if you can't see your variables, what you can do is you can go to Window, and you can go to Debugging, and these are all the different kind of debugging windows that are useful for you. We'll look at watches later. The call stack will come in very handy when we start to have one method calling another, calling another. But for now, we got the variables. And if we look at the variables, we can see each one of these that are the little green diamond shapes here, these are all local variables of this particular method. And when I say local, I mean it could be a variable that's declared inside or constant that's declared inside. As you can see, this is not really a variable. This is a constant, pi is. And these will only exist as long as the method is running. In addition to that, the class as a whole might have methods as well, or variables as well, and we'll start to see that stuff in future examples. So here we have radius, because we had read into radius. We don't see area yet, because we're right here waiting to fill area. And we do see this thing called input. And notice that input is of type scanner. And notice also that rather than seeing data, we're seeing basically this #256. What is that? Well, that essentially is kind of telling you that this is a reference to something that's on the heap. We'll talk about the heap in memory later on as well. And its a unique identifier is this 256. And so that's what the scanner is. And if I wanted to look a little bit more detail of what input is, if I expand on that, you can see that these are all the little pieces, all of the member variables of this input object and their values of this input object. There's a whole bunch of stuff that that object has. We don't have to worry about all the details of that, but just to let you know, it has a lot of details. Before we go into the next example, let's just illustrate some things about errors that might take place. For example, if I forgot to import the scanner class and I tried to run it, I'm going to get an error because it says it doesn't exist. And as I said before, if I wanted to, I could import all of the classes in Java.util, and so this would work just fine. And you can see that it works just fine. Another thing I'd like to point out is this notion of the importance of indentation. You know, supposing I didn't indent at all and I just made everything all the way to the beginning, you know, each of these lines all the way to the beginning, or if I indented in completely weird, arbitrary ways, and how difficult if we had a very extensive bit of code to understand what's going on. Look what I'm doing. I'm putting pretty much everything on one line here. It runs fine. Let me run it. And it runs fine, but it's hard to understand. I have a situation where things just aren't indented and they don't look good. One of the nice features of NetBeans is I can automatically format my code. I'm going to right-click here in the editor, and you see the format. I'm going to go ahead and format, and boom, everything is formatted nicely. Isn't that a nice thing? So there is no excuse for not having proper indentation, because you can do it with the click of a button. So now let's move on to the next example, and this one is actually an example that has some business relevance. Computing a loan, computing the monthly payments and the total payments for a loan based on the interest rate and based on the number of years, the duration of the loan, and based on the amount of the loan. So let's go with that. I'll start by just running it. So here it's asking me, what's the interest rate? 7.25. How many years? 10 years. How much? $1,500. And there we have it. My monthly payment is going to be $17.61. And in the end, after those 10 years at that interest rate, I'll have paid a total of a little over $2,100. So let's see how that took place. So let's look at some of the features of this particular example. First of all, here we're using a scanner, just like we've done before. We've created an instance. By the way, notice how it says new scanner, and what we've got is the same name of the class. What we're doing here is we're actually calling a very special method of the scanner class called a constructor. And later when we get into object orientation, we'll talk about how classes that you create instances of have a special method whose purpose is to do the initialization, and it's called a constructor. And the name of that method will be exactly the same as the name of the class. So this is one of the few cases where you might see a method that begins with a capital letter because the class begins with a capital letter. So here's where we instantiated it. Remember, input is a variable that's pointing at an object, a scanner object, elsewhere in memory, not within the mains frame on the stack, which again, we're going to talk about call stack and heap and those sorts of things many, many times during the semester. You had a little taste of it in your intro class, but we're going to dive very deeply into it this semester. So we've created an instance, and then we're using that to call methods. We're looking for a double this case. We're looking for an integer this case. So if the user had entered 5.2 years, we'd get an error here. But if the user just entered 5 here, that's fine, because it's okay to put an integer into a double, because there's implicit typecasting going on. But it's not okay to take a double and put it into an integer without explicit typecasting, and we're not doing that here. And then here we have another case where we're reading a double. So we're going to expect 3 separate user inputs here. So the next thing is some arithmetic expressions. Here we had a situation where the variables are declared and initialized in one fell swoop, and that's certainly possible to do. So this should be something you're already familiar with in both of these cases, and both of these are fairly simple arithmetic expressions taking place. Here is a case where we are doing some typecasting here, and we'll make use of this. We'll see how there's a little trick that they're doing here to make things come out with dollars and cents and not have like a whole bunch of numbers to the right of the decimal place. Making use of the typecast operator to take the value, remove, truncate out the extra places to the right of the decimal place so it looks more like dollars and cents. We'll take a look at how that fleshes itself out. It's not the greatest way to do it. There's better ways to do currency formatting, but that's taking place. That's what they're doing here in this particular example. And you can see what's taking place here. So here is the entire expression. So here I did a system.out.println, and we're passing an argument, and part of what we're passing as the argument is this expression right here. So let's take a look at the steps that take place. One thing you should always note is that things happening inside the parentheses is going to take place before things happening outside the parentheses. So the very first step here that's taking place is this multiplication. And assuming that the monthly payment was calculated as this result. So we took that result, 1525.875. We multiplied it by 100, which gave us 152587.5. Then at that point, we converted it to an integer. This is a typecast operator, which we talked about a little bit earlier. This is a typecast operator. What does that do? That just chops off what's to the right of the decimal place. And that's what we wind up with here. So that's our second step. We're truncating. So keep in mind, if you have a double value and you are typecasting it as an int, it's not rounding. We can do rounding. There's a different way to do rounding, but that's not what we're doing here. We're truncating. And then finally, what the last step was in this case was to take that value and again divide it by 100. And notice how it's dividing it by 100.0, because once we had done this typecast, we had an integer. So if I just took the integer and divided it by 100, we'd wind up with an integer, but that's not what we want. So I divided it by 100.0, and that gave us our dollars and cents. That was this rather clunky way that in this particular example, they made things come out looking more like dollars and cents. As I said, that's not the greatest way to do it. We'll talk later about better ways to do it. So that was a little bit of use of typecasting here. And then finally, let's take a look at a more complex arithmetic expression. So we got a lot of stuff going on in this expression where we're trying to calculate what the monthly payment is. So let's step through that in a little bit of detail. So here's the whole expression. It's not just the expression. Here's the whole statement that's taking place. And this is an assignment statement. So to the left of the assignment statement is the name of the variable, and to the right of the assignment statement is this expression. So if we're going to look at what are the steps that take place here, This one program statement is doing a lot of different things. The first thing that's taking place is we're declaring the variable. That's the first thing. The next thing that's taking place is in order to assign a value into that variable, we have to evaluate this full expression. Well, how are we going to do that? We're going to do that from inside out. Always think when you're dealing with an expression, the way that expression gets evaluated is that stuff happening in the innermost parentheses is going to take place before stuff happening outside those parentheses. So we're going inside out here. And so let's take a look and see what's happening inside this most inner set of parentheses, which is actually arguments to a method, which I'll talk about, of the math class, which I'll talk about. This method is called POW, stands for power. And it takes one argument and raises it to the power of the second argument. So this first argument, in order to be able to use it, in order to be able to pass this data to that method, this expression, this little expression here had to be evaluated. So that's the next thing that took place. And this expression had to be evaluated. So that's the next thing that took place. At this point, you have one argument and another argument, and we're ready to make the call to this method. So that's the next step that took place, step number 4. After that gave us back its value, now we can take that value and divide it into number 1, into this 1 here. So this division takes place, the next thing. And then the next thing that takes place within this outer set of parentheses here is subtracting that from a 1 here. And then only after that has taken place will we have this value, the loan amount, and this value, the monthly interest rate, and this value, which was this whole big Mongo expression here. And we can multiply and divide, and that's what takes place there. Finally, at that point, the full expression to the right of the assignment operator has completed, and the assignment can take place. So that assignment is the very last thing that took place. There's a lot of stuff going on, as you can see. So what is this math class and its POW function? So math is another class that is also in the java.lang package. It's also one of the things that comes to you automatically. You'll notice that we did not have to import the math class. We had to import scanner because that was in a different package, but anything that's in java.lang is automatically imported. Let's take a look at this math class. So again, where's the math class? It's in java.lang. So I'm going to scroll down here to java.lang, and we've already looked at the system class. And we took a quick glance at the string class. We'll come back to that later. Let's take a look at this math class. The math class is another class, like system, that you're not going to create an instance of. Notice look at all these methods of the math class. Notice that they're all static methods. Let me go to the system class. In the system class, and we look at the methods, look at all of these static methods in the system class. So some classes are not intended to be instantiated. All they have is static members. System is one example. Math is another example. As a matter of fact, this program that we've created called ComputeLoan is another example. The member is static. By contrast, let's go back and look at that print stream class that we looked at before. Here's the print stream class. And look at its methods. These are not static methods. None of them have the word static in front of it. Same thing was true with scanner, which was part of the java.util package. So printstream was part of the java.io package. Scanner is part of the java.util package. And similarly, it does not have static methods. So some classes have static methods, and some classes do not. Some classes have both static and non-static methods. So to get back to this math class, which is a subclass of object, and as I told you already, object is the granddaddy of all of the classes. Every single class that you can create is somehow a descendant of object. In other words, you know what else is a descendant of object? ComputeLoan. ComputeLoan is a subclass of object. And math is also a subclass of object. And if I go to some of these methods, let's go to some of these methods here. All these static methods, a lot of useful things. If you want to do trigonometry, you could do sines and cosines and things like that. We're not going to do trigonometry. You can do exponentiation, which is the POW, which that's what I should be looking at. Let's go down to that. POW takes two methods. If I want to take a look at some details, it takes two doubles. It takes the first and the second and raises the first to the power of the second. There's other very useful ones as well. A max, min, round, random number generators. So there's all absolute values. So there's all kinds of useful methods of the math class. And we just used one of them in our little example here. So how about if I just use the debugger and kind of see what's going on? I'll get right to this point right here. You know, my dog is digging on the carpet. Let me stop him. Okay, I put my dog outside. We have two dogs. We have a husky named Jax, and that's what I just put out. We have a little miniature poodle mix called Chewbacca. And Jax likes Chewbacca, but Chewbacca does not like Jax. Anyways, let's run this. I'm going to debug it, and we're going to stop at this breakpoint right here. And it's going to ask me to enter things. It's under a 7.5. Watch what happens if I give the bad number of years, say 5.2. Once again, I got an exception, right? Because it wanted to read an integer. So let me go ahead and do it again. And 7.5. And say 8 years this time. And say $20,000. And now we're here, and we have our loan amount. We can see what the value of it is. And we have our number of years, and we can see what the value of it is. And we're about to do all of this stuff. So if I want to know what the ultimate result is going to be, I can, in fact, select this whole thing, and it should show me the result, which is going to be 277.67741, blah, 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 blah. See all those places to the right of the decimal place? But if I want to take it piecemeal, like we were talking about before, if I took 1 plus monthly interest rate, that's going to be the first argument that's going to be passed to the math.pow method. And if I took number of years times 12, that's the second argument. Notice again the camel case notation here. And then, at that point, math.pow would give me its result, 1.818719, blah, blah. And then I'm going to wind up dividing 1 by that result. And now it's 0.59, etc. And then I'm going to subtract that value from 1. Which gives me that result. And finally, we get all the rest of it, which gives us the ultimate result. You know what I'm going to do? I'm going to put another breakpoint right here, which is going to enable me to figure out what we're going to print out from that monthly payment. So let me go to that next breakpoint. So here we are about to do this print. And here's our monthly payment, which has all of those places to the right of the decimal place. So let's see the steps that took place to do this kind of clunky way of getting us into dollars and cents. We have monthly, so again, remember what takes place inside the parentheses happens first. So we have monthly payment times 100. So you can see that we took a couple of places that were on the right of the decimal place and put it on the left of the decimal place. Here's monthly payment, 277.67, and here's monthly payment times 100, 27767.74, etc. So we took the two decimal places that were immediately to the right of the decimal point and put them onto the left. And then what did we do? We converted it to an integer. Got rid of everything else that was to the right of the decimal place. And then finally, what did we do? We divided it by 100, and that's what gives us our dollars and cents back as a result. That was the little trick that they used. Yeah, nice little trick. And that gave us our final result. There's some other nice examples. Here's one called display time. The display time example is making use of integer division and the remainder operator, modulus operator. So here it's going to allow us to specify how many minutes. If I put how many seconds are, it's going to give us how many minutes and how many seconds. It's going to take seconds divided by 60, and then it's going to give us the remainder. So if I want to run it, and I say that how many seconds do we have here? Let me pull this output window down a little bit. How many seconds do we have here? Say 136 seconds, and it's going to come out to 2 minutes and 16 seconds. And you can kind of see how it's going to do it. Let me go ahead and debug it. So here's seconds. Enter the integer, say 222. And here was seconds. Seconds was 222. When we divided 222 by 60, it gave us an integer value. It gave us only 3, right? And if we did the modulus, that was the remainder, 3 with the remainder of 42. And so hence we wind up with 3 minutes and 42 seconds. There are some other nice things, converting temperatures, sales tax, other nice little things that you can play around with. So that's pretty much everything I wanted to talk about having to do with Chapter 2. We are going to be doing some exercises where you will do some of these complex arithmetic operations and step-by-step sorts of things. I'll be posting some of those. And I do intend for us also to meet occasionally in class to do these exercises together. And so the next lecture that I will be doing, we start to get into the material from Chapter 3 and some of the material from Chapter 5. And this has to do with control structures. So we're talking about making decisions, which is either if statements, or an alternative to that is something called a switch statement, or for doing repetition or iteration or looping is the term that you're probably familiar with. And there are a variety of different types of loops that we can do as well. And that's what we will start to dive into the next time.